Hello there. So we're going to solve a problem here like number 42 on Quest because I know that was really the hardest one and a lot of people had questions about it. So the place to start is let's figure out the gravitational forces between these individual pairs of objects. And let me draw an arrow in here so you have a sense of what I'm talking about. You know what? I'm going to label these masses A, B, and C. I think that'll be easier to talk about. So first thing I want to do is let's figure out the force on B by C, and then we're going to figure out the force on B by A. That's a pretty simple application of Newton's law of gravitation. Fg equals g m b m c over distance squared. 6.67 times 10 to the negative 11. And mass B in this situation is 2, mass C is 2. Here's the first little issue is what is the distance? We need the distance between mass 2 and the other mass 2, and that's the diagonal of this situation here. But you can use the grid on the screen to work with the Pythagorean theorem. You know, if you go out to here, that's 5 meters, and if you go up here, that's also 5 meters. So using the Pythagorean theorem, we can figure out this hypotenuse. It's going to be 5 squared plus 5 squared. Now, theoretically, you take the square root of that, but in the bottom of this equation, we have to square that anyway. So in a way, it's really just 5 squared plus 5 squared. If you do that on your calculator, hopefully you get the same answer that I get, which is 5.336 times 10 to the negative 12 newtons. So let's now do the same thing between the other pairs of masses. And so I'm going to do Fg equals 6.67 times 10 to the negative 11. Mass B is 2, mass A is 8. The distance between them is going to be 2 squared plus 1 squared, square root of that, but then square it again. If you plug all that into your calculator, you should get 2.1344 times 10 to the negative 10 newtons. Just notice that these two are kind of different from each other, 10 to the negative 10, 10 to the negative 12. So this one's not going to have as much influence as that one. All right, next step. Since they're vectors, we have to figure out what direction they are pointing. So we have to figure out this angle, and we have to figure out that angle. And we can do it from this diagram because, of course, mass 2 is pulled directly toward the other mass 2. So this line that I drew that points toward this other mass 2, that's pointing at the angle we're interested in. And again, if you look at this as a right triangle here, we can use the distances on the grid, this being 5 and this being 5, to figure out what this angle is. And you know what? Maybe you know from math that when the legs of a triangle are equal to each other, this has to be a 45-degree angle. So I'm not going to do the math on this one. I'm just going to write 45 degrees here. I'll do the math on this one because this isn't a 45-degree angle the same way. This is 2 here, this is 1 here. And so you can use inverse tangent because that's opposite over adjacent. So here, that's going to be opposite. This angle right in here is just 1. That's a grid value of 1. And adjacent to it is 2. If you do that on your calculator, you should get 26.565 degrees. Okay, so those are our two force vectors. We want to add them up. Literally, the net force on B is equal to the force on B by C plus the force on B by A. I always like to draw a sketch of what this looks like. Not required, but I think it's a good idea because it gives you a sense of what you're looking for. So the force on B by C, that's this up here. Let me try to draw a picture of that. I'll sort of recreate the origin of a coordinate system here so that I can clearly draw a 45-degree angle, 45 degrees, and I'm just going to draw a line, and we're going to call that line, you know what, I'm going to make that a little shorter because I already said the other one's longer, so I don't want to start with a long arrow. So let's say that represents 5.336 times 10 to the negative 12 newtons. Now, I want to add this other vector to that. So I'm going to recreate another origin at the tip of that vector, this is going to get messy, because now I have to draw 26.565 degrees, into this direction. This vector over here points this way, points that way. 26.565 degrees is with the negative x-axis. So let me try to do that. I'm going to attempt to do approximately a 26-degree angle. And then the other thing is that this vector is larger than this vector over here, 10 to the negative 12. This is 10 to the negative 10th. And so I think it's going to be significantly larger. Anyway, it's going to look something like that. So that's supposed to be a 26-degree angle. This is supposed to be our vector. So the answer, which you always draw from where you start to where you end, is going to look like that. So it looks like our answer is going to point into the third quadrant. That's what we would expect to see. Okay, so let's get to the nitty-gritty of how to add these two together. The only way to add two vectors together is either if they're collinear or perpendicular. So we're going to have to find the x and y components of each of these vectors. Let's do that individually here. Let's start with this one here. Let's start with the force on B by C, 5.336 times 10 to the negative 12 at 45 degrees. I'm going to redraw that. 5.336 times 10 to the negative 12 newtons at a 45-degree angle. So we want to find the x and y components. So I'm going to start at the tip here. I'm going to drop a perpendicular, a line that is perpendicular to the x-axis. That shows me how long to draw the x component and how long to draw the y component. And I'll note that the x component is adjacent to the 45-degree angle. The y component is opposite. So to find the x component, I'm going to use cosine. Cosine of 45 is equal to opposite, which is x, over hypotenuse, which is 5.336 times 10 to the negative 12. And so x is equal to 5.336 times 10 to the negative 12 times the cosine of 45. If you do that on your calculator, you should get 3.79 times 10 to the negative 12 newtons, and it points to the right, so it's positive. For y, you would do the same thing, 5.336 times 10 to the negative 12, but you're going to use sine because it's opposite the 45-degree angle. But with a 45-degree angle, sine and cosine are equal to each other, so they have the same x and y components. Okay, let me do the same thing with the other vector, which looks like this. And this was let me remember what that angle was. 26.565. So this is 26.565 degrees, and the hypotenuse is 2.1344. 2.1344 times 10 to the negative 10 newtons. All right, let me draw the x and y components. If I start here, I'm going to draw a perpendicular to the x-axis. You want that to be perpendicular. So that's going to define how long my x component is and how long my y component is. By the same logic that we used previously, x is adjacent. So the cosine of 26.565 is equal to x over the hypotenuse, 2.1344 times 10 to the negative 10 newtons. So x is equal to 2.1344 times 10 to the negative 10 times the cosine of 26.565, and I get 1.9 times 10 to the negative 10 newtons when I do that on my calculator, but it points to the left, so I'm going to make that negative. Now, if you work with the y component, that's opposite this angle, so we're going to use sine. The sine of 26.565 equals y over the hypotenuse, 2.1344 times 10 to the negative 10 newtons. And I won't show you all the algebra, but when you solve that, you should get 9.545 times 10 to the negative 11 newtons. And it points downward, so that's a negative vector. So now what we need to do is we need to take the two x components, this x component and this x component, add them together to get a total x component. Then we're going to do the same thing with y components, this y component and that y component. Add them together to get a total y component. So if you do that, I'm not going to write it all out just for the sake of time, but if you add this number for the 1x component to the other number for the x component, you get a total force in the x direction of negative 1.8711 times 10 to the negative 10th newtons. And again, maybe I should write that out. In other words, that's positive 3.79 times 10 to the negative 12 newtons plus negative 1.9 times 10 to the negative 10th newtons. Just adding the x components together. Let me add the y components together. So that looks like positive 3.79 times 10 to the negative 12 newtons minus 9.545 times 10 to the negative 11. Okay, so if you subtract those two numbers to get the total force in the y direction, I get negative 9.1663 times 10 to the negative 11 newtons. So what we have here is the total x component, and this is the total y component. Now we have to put those together. I like to draw them. So drawing the x, I'm going to draw it in the negative direction. So negative 1.8711 times 10 to the negative 10 newtons. And then from the tip of that, I need to draw the y. It's smaller, so maybe something like this, negative 9.11 or 1663 times 10 to the negative 11 newtons. So what we're looking for, the answer, will start here, it'll end there. The magnitude is the hypotenuse of that, so it's going to be the square root of negative 1.8711 times 10 to the negative 10 squared plus negative 9.1663 times 10 to the negative 11 squared. And when I do that on my calculator, I get 2.08356 times 10 to the negative 10th newtons. That is the answer to question number 42. They're asking for the magnitude of the net force. So you're done that at that point. There's, I think, a follow-up question 43, which is the direction. So that's that angle that we want to find there. So for that, we're going to use inverse tangent of negative 9.1663 times 10 to the negative 11 over negative 1.8711 times 10 to the negative 10. When I do that on my calculator, I get 26.113 degrees. And if you're really going to be, if you're taking a test and you want to say this very accurately, you should say additionally below the negative x axis, because that's exactly what's happening there. That angle is below the negative x axis. So I know that was quick, but you can pause, you can rewind, and I hope it helps you to understand how to solve one of our most complicated problems in this unit.